Hello again, and welcome to another math class. I am Jillian. I am a teacher with Jessamine County Skills U, and also with Woodford County Skills U. And today we're going to kind of build on what we learned last week about algebraic expressions. So if you haven't watched that video, go back and watch that one first because it's going to help you a lot with this one. And we're going to start with some geometry. Geometry is just studying shapes, measuring shapes. How big are they? How much space is in there? How big are they around? Things like that. So what we're going to start with today is the area of a few different shapes. So when we think about area, we get rid of this thing here. All right, when we think about area, we're looking at the space inside of a shape. So if here we have a rectangle, the perimeter, I'll write this over here. The perimeter is the distance around a shape. So, sorry, let me set this up a little better. Okay, so the perimeter is, if you took a walk around this rectangle, how far would you walk, basically? So we're thinking about the distance around. The area, so perimeter is the distance around. The area is the space inside. So perimeter is a one-dimensional measurement. So we'll say 1D for one-dimensional. It only has length. So if this square or this rectangle, let's say it was 5 feet long and 3 feet tall, or actually to make my life easier later on, I'm going to make it 4 feet. So we'll say it's 4 feet long, 3 feet tall. If we were to walk around this, we would be walking 4 feet, then 3 feet, so that would be 7 feet, and then another 4 feet, and then another 3 feet, so that would be 14 feet altogether. Okay, so perimeter is only length. It's only going this way. Okay, area is a little bit different. It's going in 2 dimensions. It's going length and also width or height. So on this rectangle, let's imagine kind of our inch marks. So this is 4 inches long, 1, 2, 3, 4, and this is, or feet marks, and this is 3 feet high, 1, 2, 3 feet high. So let's say we kind of extend these lines, and I am just not capable of making a straight line, so forgive that, but we'll go with it. All right, so now we've divided up our shape into these squares. So square feet. So each of these squares represents 1 square foot. So in this shape, we can see there are 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 square feet. Sometimes it's written like this, SQ, feet, and sometimes it's written like that. But either way, it means the same thing. This is talking about a 2-dimensional foot, one that has length and width. Okay, so when we're thinking about area, we're measuring how many squares of any increment, so feet, inches, meters, millimeters, how many squares will fit inside of a shape. Okay, sometimes it's very simple like this, but sometimes it gets a little more complicated. So we need to use some formulas to find the area of some shapes. It's not always convenient to draw like lines. So we've come up with some formulas to help. And those formulas for the GED test anyway, you receive at the beginning of your test a formula sheet that lists out all of these formulas. So if you know how to use them, you don't have to memorize them. You just have to know what the letters mean. So that's what we're going to go over today. We're going to talk about area of a few different 4-sided shapes to get you started on that formula sheet. And over the next few days, we're just going to kind of move on down that sheet to work on the different measurements there. Okay, so let's take a look real quick at that formula sheet. It looks like this. I can get it to open up. Here we go. It looks like this, and this is what you would get on the GED test. Today, we're going to be looking at these top three: the area of a square, the area of a rectangle, and the area of a parallelogram. So we're going to talk about these top three. And then we're just going to kind of move on through the formula sheet in future videos so that by the time we're done, you have kind of a full tutorial of the whole sheet. So let's look again at our rectangle. I'm going to erase everything and start over with a fresh rectangle. So our first formula is the area of a square. So we'll make a little square here. And the area of a square, the formula is A equals S squared. So these formulas, you can use them like when we were evaluating expressions and substituting values in. You can use these formulas the same way. You just substitute your values. So what does this S mean? We know that the A means area, right? But what does this S mean? Well, for this formula, the S means the measurement of one side. So the S means the side measurement. So if this square has one side that is 5 inches long, then we can substitute this one side measurement into this formula for this S. So our new formula would be area equals, and instead of the S, we have our side measurement. So we use our side measurement, 5 squared. So that would give us the area equals 25, 5 times 5. Okay, so let's look at another example of how that might all go. So we'll put another square, just like the other one. And let's say this square has a side length of 16.5 meters. And we have the same formula, A equals S squared. So this formula applies to all squares. We can use it for any square to find the area. So we have our side measurement is 16.5. So our area equals 16.5 squared. And we can put that on the calculator. I'll show you how to do that. So you would put in your 16.5, just like that. And then you can there are two buttons you can use for an exponent like this. So one button you can use is the regular exponent button, which is this one right here. And you could put this and see how it moves your cursor up to the top there, so that now you can put in your 2, and that makes it squared. Okay, and then you can hit enter for that. The other thing you can do, because so many problems use an exponent of 2, raise things to the power of 2. It's a very common one that you see in a lot of formulas. They do have a shortcut key for that, and that's this x to the second power right here. So you could put in 16.5 and then push this x to the second power, and you get that squared automatically. It saves you one keystroke, but it's handy sometimes, but you get the same answer. So my answer here is area equals 272.25 meters squared. So this squared is not saying we square this number. It's just referring to how it's not just a length meter, it's a square meter. Okay? All right, so let's move on. So that's how to use that formula for a square. Let's look at the formula for a rectangle. So let's put up a rectangle up here. The formula for the area of a rectangle is area equals length times the width. And when you see two letters right next to each other like this, we are multiplying them together. So this is the same as saying length times width. So these letters, we had S meant side earlier. These letters mean length and width. Okay? So let's say our rectangle here is 12 inches long and 8 inches tall. We can put our problem down here. We can substitute the 12 inches for the length and the 8 inches for the width. Now, it does not matter which one is which. When you're multiplying two numbers, it doesn't matter which one comes first. Either way, you get the same answer. So 12 times 8 is the same as 8 times 12. So we'll put it in, we'll put the 12 as the length this time. So 12 is the length times 8 is our width. So the area of this rectangle is 96 inches squared. Okay, and same thing here. This squared is just talking about how these inches are not the same as these inches. These inches up here are just length inches. These inches here are length and width inches, so they're square inches. Okay, let's do another one with a rectangle. Let's say this rectangle has a length of 4 2/5 centimeters and a height of 2 1/4 centimeters. Okay, so I'm going to use my calculator for this. So we still have our same formula, area equals length times width. So our area equals 4 2/5 times 2 1/4. So on the calculator, just as a refresher, our mixed numbers like these are the second function of the fraction button here. So you would do second and then the fraction button, and you get this blank mixed number. Okay, so it's 4 2/5 times 2 1/4, and we end up with 9 9/9. So the area of this rectangle is 9 9/10 centimeters squared, or square centimeters. Okay, so there's our kind of two easiest ones, our rectangle and our square. We have the side squared for the square. For the rectangle, we have the length times the width. So now let's look real quick at a parallelogram. So a parallelogram is a four-sided shape that has two sets of parallel sides. A parallelogram can sometimes look like a rectangle that just got kind of tipped over a little bit. So it'll look like this. So parallel just means that these sides could go on and on and on forever and never cross each other. So here are our two sets of parallel sides. We have the top and the bottom. These are parallel. I mean, if I could draw a straight line, they would be parallel. So they would go on and on forever and never cross. And then these two sides are parallel to each other. So the opposite sides are parallel. A parallelogram is a little weird to take the measurement of, because you don't just use the side measurements. There's a third measurement that you need. So if you look at the formula sheet, the area of a parallelogram is the base times the height. So this B stands for base, and this H stands for height. And when we're looking at the height of an object, we do not usually measure, or really ever measure, along the side of that object. So like, for example, if you have a little house here, let's pretend with a little chimney, and you were going to measure the height of this house, you would not take your tape measure and lay it along the side like this, right? You would have somebody down at the bottom and you would measure straight up to the top of the house. That's how we measure the height of objects. So the side length of a parallelogram is not helpful to us when we are finding the area, because for the area, we need the height, not the side length. So I'll show you how that will look. So usually with a parallelogram, they'll give you the base. So let's say this base is 26 inches long. And then let's say this side length is, I don't know, 22 inches long. What they'll do is they'll give you the height like this. They'll make like a little dotted line like this. Oh, my lines are so crooked. Forgive them. And then they'll show a little box here to show that this is a right angle. And then they'll tell you this measurement. So maybe this is 20.5 inches. Okay? When you are looking at a parallelogram, understanding what this formula means is going to be very helpful, because if you use the wrong measurement, if you use the side measurement instead of the height, you're going to get the wrong answer. So for the parallelogram, you'll use the base length, the length of the base, and then you'll use this height measurement. So for this one, the area of the parallelogram would be 26 times 20.5. So don't be fooled by this extra measurement here, because you need this one, the height, for this formula. So, and 26 times 20.5 gives us 533 inches squared. Okay? All right, let's do one more parallelogram just so we can make sure we've got the hang of this. So we'll make it kind of a crookedy one. Okay, so for the other way that you might see this is, instead of having the box on the outside like we had it before, like over here, they might also put the box on the inside. So they might put a line like this and then the box here. So let's say this is 3.5 feet long, and the side length, let's say it's 9 feet long, and this measurement here, let's say it's 7 feet. Okay, so same formula, area equals base times height, and our base, so area equals 3.5, that's our base, and our height is 7 feet times 7. And we end up with, I'll put it over here this time, 24.5 feet squared. Okay? All right, let's do some practice. Let me think, how did I do this before? All right, let me erase everything out and pull up a little bit of practice here. So again, with this practice, what I'll do is go through each problem individually for you. And then what you can do is go ahead and do the problems. And you can kind of pause me here, go through, do the problems, find the area of each shape. And then fast forward to the end and you'll see all the answers up on the screen. Or you can follow along with me, or if you get one wrong at the end, you can rewind the video to where I'm working out that problem. So we're going to kind of go through and do each of these individually. and see what we get. All right, so this first one, and I'll just put our formulas over here. Oh, whoops. Okay, so our first formula is for the rectangle. We'll put this like this. The rectangle, the square, and the parallelogram. All right, area for a square is the side squared. Area for the rectangle is the length times the width. And area for the parallelogram is the base times the height. So our first step for all of these is to choose the formula that we want to use and then apply it and then write our answer down. It's pretty simple. All right, so this first shape is a rectangle. So we're going to use this formula, the length times the width. So we have the length and the width. So we'll do 12.6 times 9.8. And that gives us, I'll write it down right here, 12.6 times 9.8 gives us 123.48 inches squared. Okay. How about this next one? So here we have some mixed numbers. So this takes a little bit of time to put into the calculator, but we have a parallelogram here. Okay. So we're going to use this formula, the base times the height. So we have a base of 6 3/4 centimeters and a height of 2 1/4 centimeters. So we're not going to use this one. We're going to use this one right here. So let's see, I'll write this one down here. 6 3/4 times 2 1/4. Let's see, 6 3/4 times 2 1/4. And just to refresh us, when you are looking at the calculator for these, the calculator will always give you your answer. If it's going to be a mixed number, it'll give it to you as an improper fraction. So just as a review of another video that I did earlier, in order to change an improper fraction into a mixed number, you're going to use this second function right here. Let me just get really close so you can see it. It's a little fraction and then a little mixed number symbol. So you'll hit second and then this button right here, which is, it says x10 to the nth power on it. And up here is the function we're going for. And it's going to put something on your screen like this. And then you'll hit enter. Oh, whoops. Then you'll hit enter and it'll give you your answer, 15 3/16. So just a little review on how that all works. I always say learning the calculator is half the battle with this math test on the GED. All right, here we have another parallelogram. So this one has a base of 11.7 meters and a height of 10.25 meters. And we don't even have a side measurement, so we don't even have to pick. So we'll do 11.7 times 10.25. I'll put this here. 11.7 times 10.25. And that gives us, 10.25. 119.925 meters squared. Put that one in there. Okay. All right. For this one, we have a square. We have a square with a side length of 16 feet. So we can come over here to our square formula. The area equals one side squared. So we do 16 squared equals 256 feet squared. Okay, pretty simple. This rectangle is 37 miles by 6 miles. So it's a rectangle. We're going to use this one. We're going to use our length times width. So we do 37 times 6, and we end up with 222 miles squared, or square miles. Okay. Here we have another parallelogram. So we're going to use this area equals base times height. So we do our base, which is 0.25, our height, which is 0.4 inches. So 0.25 times 0.4, and we get 0.1 inches squared. Just itty bitty. All right, and here we have one more parallelogram, our last one. So this one, we're going to use our base measurement, 19 millimeters, and the base is just the top or the bottom. For a parallelogram, this could be sitting on this side or it could be stood up the other way. It doesn't really matter. Whatever side it's sitting on is the base for this exercise here. So either the top or the bottom, and these are both the same measurement. So this top is 19 millimeters, this bottom one is 19 millimeters as well. So for this one, we do 19 times 11, and we get 209 millimeters squared. All right, this next one, we have another rectangle, and it is 15 3/8 inches by 42 1/5 inches. And again, this calculator is going to give us, when we do this length times width thing, the calculator is going to give us a real, super improper fraction. I don't know why that's the default on these. So we change it to a proper fraction with that second function there, and we end up with the area is 648 and 33 over 40. So we'll put this here, area equals. All right, and then the last one, we have another square, and it's 5/7 of a centimeter on one side. So our problem is 5/7 squared. And in your calculator, one tip with this one, let me clear out the screen so it's just this. You'll put in your fraction like regular, but make sure with this one that you push over to get yourself out from under that fraction. So see how the little cursor is down in the denominator? You need to get it out before you do the square. Okay, you got to get it out of the fraction to complete it. So it's squaring the whole fraction and not just the denominator. So we square that and we end up with 25 over 49 centimeters squared. All right. I hope that clears up a little bit of this formula sheet for you. I know it can be a little bit tricky. And if you have any questions, ask down below. I'm also going to link some exercises that you can do to practice these formulas that I think would be really helpful. But if you have questions, post them here, post them on our Facebook, email us, get in touch and we'd be happy to help you out. Anyway, tomorrow we'll be working on a little bit more of this formula sheet. And until then, have fun finding the areas of some quadrilaterals. We'll see you soon.